Hello and welcome everyone. Our today's question is search in a rotated sorted array. So we have an array. The array is sorted. So we can apply binary search, but it is rotated. Still we can apply binary search, but with some conditions. So for binary search, we have L as 0 and R as n minus 1. So we will find the mid 0, 1, 2, 3, 4, 5, 6, 7, 8. So its mid is this. So we have to find the k element. If you carefully observe, first we will check, is the mid element the target element? No, in this case it is not. So if you observe, the left hand side is sorted. So we will have n sub array which is sorted either left hand side or either right hand side. So in this case, the left hand side is sorted. So we will write it like this. If array of L less than equal to array of mid, which means left hand side is sorted. So we will check. So in this left hand side, so we will check, is k is in the sorted array. So how do we check? Just we will write it like this. If a of L is less than equal to key and key is less than equal to array of mid, which means our key lies in the left hand side. If this is true, which means our key lies in the left hand side, so we will reinitialize our R. In this case it is not, so we have an else condition here. So as you can see, our left hand side is sorted, but our key does not lie in this array, in this sub array, in this sub array portion. So we will reinitialize our L to right hand side. So we will check in the right hand side. So we will change our L to mid plus 1. So this is mid. So we will check in mid plus 1. So this is. So now find the mid. So 5 plus 8 is 13. 13 by 2 is 6. So this is our mid. Just check. Is this the key value? No, it is not. So we will check, is the left hand side sorted? No, it is not. So this condition is not true. So we have an else condition here, which means our left hand side is not sorted, our right hand side is sorted. As you can see, from mid till R, we have an sorted array. So we will write it like this. Our right hand side is sorted. So just check, is it our key lies in the right hand side, which means our key is greater than mid and our key less than array of R, which means our key lies in the right hand side and our right hand side is sorted. We already checked. So in this case, if key lies in the right hand side, so we have to go to right hand side, which means we have to reinitialize our L to mid plus 1. If this is not the case, which means in this case our right hand side is sorted, but on the right hand side key is not there, so we will move to left hand side. So we write it like this: R is equal to mid minus 1, which means go to left hand side. So we will reinitialize our R to mid minus 1. So this is, and this is the mid element. So just check, is the mid element equal to our key element? Yes, it is. So we will return true. So in this case, our key is there. So let's take one more test case. 3, 5, 1 and 2, and our key is 6, and this is our indexes. L at 0, R at n minus 1. So just find the mid. So 3 by 2, 1. So this is our mid element. Is the mid element equal to key? No, it is not. So our next condition is, so we have to check, is our left hand side or our left sub array is sorted? Yes, in this case it is sorted. So just check, is the key lie in the sorted array? So this case, no key does not lie in the sorted array. So we have to move to right hand side. So we will reinitialize our L to mid plus 1 here. So next to find the mid element, 5 by 2, which is 2. So here, is this element equal to key? No, it is not. So just check, is the left hand side sorted? Yes, it is sorted, and key lies in the left hand side. So in this area from L to mid, it is sorted, but key does not lie here. So we will move to right hand side. L is here and mid is here. Is the mid element equal to key element? No, it is not. So for that we have to also write mid element is equal to our key. If it is, we have to return our index. Index is mid. So is the mid element equal to key? No, it is not. Our next condition is left hand side sorted? So from L till mid, yes, it is sorted. And key, so we have to check in this area whether key lies there. No, key does not lie there. So we will have to move to right hand side. So L is equal to mid plus 1. Now L is not smaller than or equal to R. So we will move out of the while loop and we have to return minus 1. So that's the approach. Let's code it up. So that's it is the code. So first initialize your L and R pointer and run a while loop. Then find your mid element. Then just check, is the mid element equal to key element? So we have to return the mid element. So else condition is left hand side sorted. So we have to write it like this. So means our left hand side is sorted. From L till mid, we have an sorted subarray. So just check, is key lie there? Means key is greater than left and key is smaller than mid. Means key lies in the left hand side. So we have to move our R pointer. We are moving in the left hand side direction. Then if it is not, then we have to move to right hand side. So else block means our left hand side is not sorted, our right hand side is sorted. So just check, is the key lies on the right hand side? Means our key is greater than mid and our key is smaller than the right hand side element. So if it is, then we have to move right hand side. We have to reinitialize our L, and if it is not, then we have to move to left hand side. So that's the approach. Its time complexity is log n and space is constant. So why is time complexity log n? Because we are utilizing binary search and its time complexity is log n. So I hope you got this, and if you like this video, click on the subscribe button, is appreciated, and thank you all for watching this video.